لسه حافظ لسه بس كليكيت share content باش
یک دقیقه استم دبیره به مداره حالیاً تو کم دانلود نکرده
أو تأثير حاجة أما لعبة
اوکی دي حاجة
join with computer audio share screen
Good morning, everyone.
Good morning, Doctor.
Good morning. This is Shaheen Abdul Karim with you from University of Duhok. I'm going to be the host of your session. The session is broadcasting also over the YouTube, and it's going to be registered. I hope you have a good time with us. Also, I would like to ask the panelists to be prepared to share their screen when it's their turn to make their presentation. We are happy to have you here in the session and wish you all the best. Thank you.
Good morning, everyone. I think we are still missing Dr. Hana and Dr. Ola, right? Dr. Sahad? Dr. Shaheen? Dr. Shaheen? Good morning, everyone. I'm pleased to start the 13th session, 13th technical session for the Women in Science Without Borders conference hosted by University of The Hague and the Women in Science Forum, World Forum. We will have 5 talks today, starting with Dr. Rayhan and ending with Dr. Ola. Hopefully you will find it very beneficial and very interesting. So we will have technically 2 parts of the session. We will start with the talks one after the other, and we will keep the questions at the end as requested by Dr. Amal. So Dr. Rehan, are you ready to go?
Good morning, doctor. Yes, I'm ready.
If you are ready, please open your cam if you'd like to, and share your screens.
It's okay now.
Thank you very much. Yes, it's okay.
Thank you.
So the stage is yours. Thank you very much.
Thank you, dear Doctor. Assalamu alaikum wa rahmatullahi wa barakatuhu. Thank you, University of The Hook and Women in Science Without Border, to giving me this chance. I am Rehan Saadi, PhD student at Scientific Research Center, Suran University, Iraq. This is my PhD project entitled Phytochemical Analysis of some native plant species of Kurdistan and study of their potential for synthesis of bioactive nanostructures involved chemical transformation, under the supervision of Professor Dr. Said Muhammad Sajjadi. As I mentioned, I am PhD student at the Scientific Research Center. So let me give you a brief introduction about our center. Suran University is located in Kurdistan, region of Iraq. It's northeast of Erbil. And the university has a very advanced scientific research center located in Science and Engineering building of university. And it consists of 6 departments: nanotechnology, phytochemistry, biogeoscience, earth sciences, GIS and remote sensing, biomedical and environmental department. The center has advanced devices such as XRD, SEM, remote sensing, and advanced microscope. At the center, there are active academic staff directed by our dean. The dean of center is Professor Dr. Kamal Kolo. He has PhD in petroleum geoscience from Bucharest University in Romania, and other PhD from Belgium. And my supervisor is Professor Dr. Said Muhammad Sajjadi, head of phytochemistry department. He has PhD in phytochemistry and green nanotechnology, and he is one of the world's highly cited author in chemistry. Now I am going to present a paper entitled Waste Chicken Eggshell as a Natural Valuable Resource and Environmentally Benign Support for Biosynthesis of Catalytically Active Copper Eggshell, Magnetite Eggshell, and Copper Magnetite Eggshell Nanocomposite, as a novel work of my supervisor, Professor Dr. Said Muhammad Sajjadi, and his co-authors. Outline. There are 3 parts: introduction, experimental, including preparation of plant extract, and green synthesis of copper nanoparticle, inside green method. And we have preparation of copper magnetite eggshell nanocomposite, result and discussion, including the characterization techniques of all of nanocomposites by instruments. And finally, we have conclusion. Green synthesis of copper magnetite eggshell nanocomposites through an environmental and economical method using aqueous extract of Orgies muscula plant and waste chicken eggshell without any surfactant. The fossil and clean synthesis, simple preparation procedure, excellent properties, and low cost for the preparation of nanocomposite allows this nanocomposite for uses as catalyst in the reduction of 4-nitrophenol and other dyes in water at room temperature. Introduction. Nanotechnology has expanded in a global market over the last few years due to its application in diverse fields. Phytonanotechnology provide a new avenues for the synthesis of nanoparticles, which synthesized by with novel green method using biologicals like plant, fungi, and yeast, bacteria. As you know, plant can use inorganics such as carbon dioxide and water from roots through photosynthesis to produce primary and secondary metabolites inside plant-living organism. Primary metabolites like amino acid, sugars, carbohydrates, and ascorbic acid, and secondary metabolites like terpenoid, alkaloid, flavonoids, and these primary and secondary metabolites act as electron donor to reduce metal ion to metal nanoparticles. Using of eggshell as substrate in this work, using of bio-derived materials as environmentally benign supports and bio-waste materials such as eggshell has been used as catalyst supports in expensive adsorbent for removal of ionic pollutants and dyes from the aqueous medium due to decreasing the agglomeration, increasing surface area, increasing stability of nanoparticles, and preventing over stoichiometric use of metal salts. Copper nanoparticles play important role in overall catalytic performance, but the difficulties of copper nanoparticle is quantitative separation from the reaction mixture and impossibility for use due to over stoichiometric use of copper reagent and their agglomeration. In order to solve this problem, copper nanoparticles immobilized onto solid supports such as eggshell in this work. Experimental part, our plant is Orgies muscular plant. Orgies muscular plant, locally known as Sahlab al-Masri, from the family of Orchisidia, used for medicinal purposes for nervous muscular disease and cardiovascular disease, chronic inflammation. Preparation of leaf extract of Orgies. For preparation of leaf extract, some grams of dried leaf extract mixed with double distilled water, then by stirring for 30 minutes at 70 degrees centigrade, followed by centrifugation and filter to obtain Orgies muscular plant extract for further uses. Green synthesis of copper nanoparticles using Orgies. 10 milliliter of copper salt solution mixed with some milliliters of plant extract, then by shaking for 20 minutes until the color change, which indicates the formation of nanoparticles, and then by centrifuge we can separate the nanoparticles. For preparation of copper magnetite eggshell nanocomposite, is done by mixing powder eggshell with the plant extract, then adding some grams, 0.5 grams of iron salt and 0.2 gram of copper salt in alkaline medium by dropwise, then followed by heating to 70 degrees centigrade for 3 hours. Change of color of mixture indicating the formation of nanocomposite, which monitored by UV. Result and discussion. Preparation of copper nanoparticles using aqueous extract of a plant. As you know, the role of a plant in biosynthesis of nanoparticles is included in 3 steps: reduction, growth by cubic agent, and stabilization. The bioreductant in a plant act as base, as you see in this mechanism, act as base and can donate electron to metal ion, which have a free orbital through the reaction of Lewis acid base to reduce metal ion to metal zero valent, which is metal nanoparticles. UV visible spectrum of our plant extract. Spectrum A is for plant extract, and spectrum B is for copper nanoparticles. In plant extract spectrum, there are 2 bonds, 2 main peaks The first one, band one, is correspond to cinnamon system. This one is cinnamon system. It's about 337 nanometer, correspond the non-bonding electron to pi star exciting electron of electron transition. And the band 2 is corresponding to conjugated double bond inside the benzyl system at 262 nanometer. And these two bonds is in general used as a fingerprint for most of the flavonoids or phytochemicals inside the plant. And in spectrum B, we have the spectrum of copper nanoparticles. The peak at 575 nanometer indicate the surface plasmon resonance of copper nanoparticles. And this spectrum is start with near UV, as you see. As this indicates that this nanoparticles is synthesized through green method. And which is absent is if the method is non-green. For example, for physical or chemical green, we cannot see this one. Only the signal will be at visible. The presence of all functional group of phytochemicals in the spectrum of, in the B spectrum, which is spectrum of copper nanoparticles, indicate that this functional group of phytochemicals absorbed by the surface of the copper nanoparticles. A is spectrum of plant extract, and B is spectrum of copper nanoparticles. HPLC analysis of plant extract, HPLC chromatogram indicates that our plant is rich source of phytochemicals and antioxidants, including rutin, myristin, chlorogenic acid, caffeic acid. We have conferol, and these phytochemicals or antioxidant can donate electron to metal ion and reduce it to metal zero valent. Field emission SEM of eggshell confirmed that eggshell is a macroporous network. This horse is a macroporous network, which help to easily form nanocomposites with copper or with magnetite. And we have elemental analysis, EDAX. Elemental analysis revealed that eggshell is composed of from carbon, oxygen, and we have calcium. XRD powder pattern of nanocomposite shows a strong and sharp peak at 2 theta 29.5, which is a characteristic peak of calcium carbonate. Main component of eggshell indicate that the level of substrate is more than the ratio or level of other compound in the nanocomposite. And this peak 220 dominant peak indicate that the system is cube. EDAX spectrum of nanocomposite approved the presence of copper, iron, and this spectrum indicate the purity of nanocomposite. And the presence of these signals is the signals of substrate, which is eggshell. Field emission SEM image of nanocomposite is to determine shape and morphology of nanocomposite, and confirmed that copper and magnetite homogeneously distributed on the surface of eggshell. And this nanocomposite used as heterogeneous catalyst because it's composed of from two different catalysts, which is copper and magnetite. TEM image of nanocomposite indicates that the prepared nanoparticle are spherical shape and have the size between 5 to 15 nanometer. VSM, vibrating sample magnetometer of nanocomposite, indicate that the value of magnetic saturation here is about 6.37 EMU, indicating that this nanocomposite have magnetic nature, and thus the catalyst could be simply separated by fixing magnet near to the reaction vessel. To evaluate the catalytic activity of copper magnetite eggshell nanocomposite through reduction of variety of dyes in situ, the synthesis of copper nanoparticles on the surface of eggshell yields uniform composites with strong catalytic activity that can reduce some dyes, like, for example, we have nitrophenol reduced to aminophenol. Nitrophenol is toxic, and when it reduced to aminophenol, to be less toxicity, and this aminophenol can be used as a primary materials for pharmaceutical application and medicinal uses. Sorry. FE field emission SEM image of recovered nanocomposite revealed that nanoparticles are identical in shape and size, even used after 7 cycles. Conclusion. In conclusion, it's described a fossil green rod to prepare copper magnetite eggshell nanocomposite using aqueous extract of leaf of Orgies muscula as stabilizing and reducing agent. The nanocomposite characterized by using all of these instruments. The formed copper and magnetite particle uniformly distributed on the eggshell surface. The research opened a new insight to design low-cost, highly active, stable catalysts for reduction of nitrophenol and other dyes in water at room temperature. The nanocomposite could be readily recovered and reused for several cycles with no loss of activity. And thank you for your time.
Thank you very much, Dr. Rehan. And we are now moving to Dr. Heja. Are you there, Dr. Heja? So Dr. Tubi Heja is currently a PhD student at University of Salah ad-Din. She had her BSc and MSc on 2009 and 2015. And she is a specialist in the biosensors, nanotechnology, biosensors, chemosensors, and nanoparticles engineering. Are you with us, Dr.
Yes,
Heja?
Hi, good evening.
Yes.
Good morning, actually, not evening.
Can you prepare yourself, please, for the presentation?
Okay.
Yes, Dr. Rafid.
Just
Dr. Rafid?
so should I start sharing my slide?
Yes, your slides available now. Go on, please.
Okay, so I can start the presentation. So my name is Haja Omar. I'm a PhD student, and I work as a conductor in Salahuddin University. And today I'm happy that I will participate in your conference as Women in Science is a really good idea about me. So I'm going to start my presentation. For the first, I just give some brief information about what is the meaning of the word nano. So why we all use the word nano, and everywhere in the world we are just going to work and we are going to have articles, research papers, and every field in life is just going to be in a nano scale. So nano is a Greek word which is called nanos, and it's a prefix used to describe 1 billionth of something. Nanometer is 1 billionth of matter. Human here is roughly near to 50,000 to 10,000 nanometer across. Your fingernails is grows daily near to 1 nanometer in each second. Nanoscale refers to the measurement of 1 to 100 nanometer, and we have virus, which is have near to 17 nanometer long. A cell membrane is about 9 nanometer thickness, and so on. So as we can say that nanoscience is truly an interdisciplinary field with its core participant, which is chemistry, physics, biology, and engineering. So we can say that nanotechnology is the combination between these 4 different sciences. So we get a new science, which is called nanotechnology. What's nanotechnology? For each one who want to start working with nano, you should design your work, what you are doing in your article, research paper, or your thesis. Nanotechnologies is first designing. You should design what you are want to prepare or synthesis, and after that characterization, then production, and at the end you get the structure and use it for your own application. For nano, sometimes we use quantum mechanics, which is using directly or indirectly for our synthesis. The paper that I will participate by it for our conference is fluorescence immunoassay based on the nitrogen dropped carbon dot for detection of nuclear matrix protein NMP22 as a biomarker for early stage diagnosis of bladder cancer. I just synthesis nitrogen dot carbon dot, which is a nanoparticle for detection of human nuclear matrix, which is the reason for bladder cancer. It can say that it is chemical, biological biosensors. According to the abstract, I just mentioned that a selective, fast-acting, and eco-friendly fluorescence immunoassay technique based on nitrogen dot is proposed, and the nitrogen dot carbon dot is synthesis between the citric acid and urea by using hydrothermal method, and the carbon dot is conjugated with a kind of antibody which is specific for recognizing NMP. This antibody is monoclonal antibody. So by a conjugation, for conjugation this antibody with our nanoparticle, we use it method which is called EDC NHS amidization technique, and we determine our protein, which is NMP, and we get the detection limits near to 1.3 to 16.3 nanogram per ml, and also we have a good recovery for our work. As we know, bladder cancer is a kind of cancer, and it is a kind of malignant near to the prostate cancer also. We have different ways can before it's used for diagnosis of bladder cancer, but which is called cytology, gold standard for non-invasive monitoring, and nuclear matrix protein. But actually, these two methods, it is really cost effective. So we are trying to find a new and less cost technique for detection this protein, and actually we get the new way for finding this way, this technique, and we use it. And the result is very hopeful that we get good result, that this technique can be used in future as a lab test for diagnosis of bladder cancer. Fluorescence immunoassay based on nitrogen dot carbon dot as label for the detection of human nuclear matrix protein. First, we are just synthesis our nanoparticle between citric acid. We mix citric acid with urea, and we put it in autoclave in a temperature 180 centigrade for 6 hours. Then we check the fluorescence of the nanoparticle. So after that, we conjugated this nanoparticle with EDC, NHS, and our antibody, which is specific for NMP. That antibody is abbreviation is MAP, which is called monoclonal antibody. So when we conjugated this antibody to our nanoparticle, we saw the enhance of fluorescence, as it's clear here. We saw the enhance of fluorescence, which indicate the conjugation of antibody to our nanoparticle. After that, we added our target, which we want to detect it, which is NMP. So as it is clear in the photo, the fluorescence start to decrease. With different concentration of our target, the fluorescence is quenched gradually. TM image of CD of nitrogen doped carbon dot and UV visible absorption spectra and fluorescence emission spectra. Here we mentioned, as we can see, of 4 nanometer, and the distance between the particles is near to 0.21 nanometer. And here is the size distribution of our nanoparticle, which show that most of the nanoparticles that we get have 4 nanometer in size. And the UV visible spectrum shows that peaks in 365, which is for M pi, and also peak in 260, which is for pi transition, that is indicate the formation of our nanoparticle. And the fluorescence emission peak is near to 500 nanometer for our nanoparticle.
Hello. Dr. Haja. Dr. Haja, are you still with us? She was disconnected apparently. Dr. Hana. Dr. Hana is not coming as well. Dr. Lafit, are you ready to present now?
Yes, I'm ready.
So,
Yes.
let me introduce you. Trying to wait for Mrs. Haja or Dr. Haja. If she couldn't come, please go on with your presentation. So Dr. Rafid
Yes.
is a mechanical engineer who was born in 1970 from the Qahr, Iraq. He had his degree, his bachelor degree in mechanical engineering from Baghdad University in 1993. And he had his MSc from University of Technology in solar energy in 2005, and he had his PhD from in the Energy and Thermal Engineering department at University of Basra. MashaAllah, I have been in all universities of Iraq. In 2009, he has he's a very active academic. He's been working at the University of Yaqar since 2009, I think, and he's been working as academic and in administration positions and head of committees. He has a number of postgraduate students and over 45 scientific paper and 5 patents. You will need a specific presentation just for you to present you, Dr. Rafid. So we are pleased to be with you, that you are with us today. Please go on with your presentation.
Thank you. Thank you very much. Good morning, all. Ladies and gentlemen, my thank you for the Women in Science Without Borders and the University of The Hague. Thank you so much for this forum for Women in Science. My paper is evaluation of thermal state for some overhead lines in Nasiriyah city, Iraq. Introduction. In recent years, Iraq witnessed generally and the southern regions especially growing demand for electrical energy, as well as technological progress in recent periods, which requires high electrical energy. The increase of energy requires electrical lines capable of transitioning high capacities. On the other hand, the lines suffer many problems due to the lack of effective monitoring or lines carrying capabilities over their load capacity. In order to operate line safely and efficiently, these lines must have high quality electrical and mechanical properties. To achieve this requires either building new lines or to use superconducting conductors called HTLS, high temperature low site. These lines require high possibilities to save time and cost. There are alternative ways to operate the overhead lines in the distribution networks at the maximum possible capacity without exceeding the permitted limits or without causing the damage to the conductor is the study of the thermal state of conductors. This study depends on weather conditions. This technique is known as the DLR, dynamic line rating. The aims of study. There are two aims for this study. The first is the effect of some properties related to the conductor, type of conductor, material, and size of the conductor, and the current load of the conductor is studied numerically based on the weather conditions in the city of Nasiriyah in southern Iraq, which considers the most hard regions by the weather conditions, because you know in summer is very high temperature, and in winter is very cold. The second aim is knowing the effect of climate weather conditions on the operation conditions of fires using ANSYS code program. There are many mathematical equations used in this study. The first one is for laminar flow equation, and the second is for turbulent flow equations. For laminar content equation, you know, this equation, and for continuity and the momentum equation, X and Y and Z directions. This momentum equation for laminar, and for energy equation and this equation, and for turbulent flow equation also there is continuity and momentum in three dimensions that Y and X directions, and energy equations this equation. Also, for heat losses, this is for heat losses from the conductors measured or calculated by this equation, I square R over AL 1 plus alpha T minus 2093. This equation, current and resistance of a conductor, area of conductor, L is the length of the conductor, and this the temperature, coefficient of resistivity at T temperature in Kelvin. Okay, and also the result, we measure the criteria for the heat transmitted from the conductor by this standard for Nusselt number, this dimension number. This is equation for crosswind between the conductor and the wind direction, and the Nusselt equal this equation for parallel wind, and where Reynolds number is Vd over nu, which is nu kinematic viscosity, and V velocity of wind, and D diameter of the conductor. Results and discussion. Before discussion our results, we compared our results with the other papers, previous papers for Machnova I and Machnova K and Taylor. This is the paper. We compared our results with him. And we see for the wind speed and two-dimensional study for the conductor temperature, we see the effect of wind speed on the conductor temperature. This is decreasing the temperature from 3025 Kelvin to about 200 or 300 Kelvin, 25 degree between the speed of wind, between zero speed and to about 14 meter per second for wind speed. The effect, maximum effect between the 0 and 1 meter per second, this maximum effect. And the other is very, very low decrease to the temperature of conductor. The other comparison between our study and 14 reference for wind speed with the three-dimensional modeling, we see there is a low difference between our study and the other study of this reference. Also, the other figure of our results between to comparison the variation of conductor temperature with wind speed for aluminum conductor, where the aluminum cross-sectional area 93.27 square millimeter. We see that the three-dimensional parallel wind is the maximum temperature for conductor than the other crosswind, two-dimensional and three-dimensional, because the effect of parallel wind is higher than the effect of crosswind on the conductor. The other results is variation of conductor temperature with the wind speed for aluminum conductor and the cross-sectional area 65.82 millimeter square. Also, for the parallel wind and crosswind for two and three-dimensional, we see also that the same effect of the previous results of the other cross-sectional area. The other also the variation of conductor temperature with wind speed for copper conductor. This is the first that was for aluminum conductor. This for copper conductor. Copper conductor trend the same effect, but the different temperatures. We see that the aluminum has higher than this temperature because the conductivity of copper, conductivity for electrical and thermal resistance is higher than the aluminum. Therefore, we prefer to use the copper conductors in our networks in electrical because it has high conductivity for electrical current and power and thermal mechanical resistance. The other the same as this one, but the different area we see the same trend of curves lowering between the three-dimensional and two-dimensional. And parallel wind, we see this is the green curve for parallel wind, and the other for crosswind. We see the parallel wind has a low effect on the temperature of conductor than the crosswind. Also, this curve of variation of Reynolds number with Nusselt number. You know, the Nusselt number is the dimensionless number for heat transfer, convective heat transfer. We see the effect of Nusselt number on crosswind higher than the parallel wind speed, the parallel wind direction. That mean the conductivity or the convective heat transfer for crosswind is higher than the parallel wind. This is for Reynolds number between 0 and about 10,000 number. This is for the cross-sectional area 65.82 square millimeters. And also, this is the comparison between the current passes through the conductor. We see the conductor temperature and the ambient temperature. When decreasing the ambient temperature, the conductor temperature also increased because the current causes the high losses and high temperature through the conductor. When increasing, see this is the lower in red, the lower current, lower power, and the 400 is higher power. We see in that the effect of higher power passing through conductor is higher than the low conductor because the losses and heat dissipated through the conductor. Also, this is for current and conductor temperature for 3 conductors with the different speed of air. This is for copper conductor when the velocity 0.6 meter per second, and this is for velocity 5 meter per second. We see that the higher curve is for low cross section because the dissipation is very low. But when the cross section increased, there is lower temperature. That is give us the equation of the equation of heat dissipated from the conductor is proportional to the line to the length of line, and in reverse proportion to the area of a cross section. Also, this is the variation of conductor temperature with the current for aluminum conductor, the same trend as for copper. Also, the small cross section and the small velocity is higher than the higher temperature and higher cross section. Conclusions. The first conclusion is when the speed and direction affect the thermal behavior of overhead conductors, where the temperature of the conductor exceeds the permissible limits, while the conductor temperature in the crosswind is less than the permissible limits, which means there is possible to increase the current capacity. 2. Dependence on the estimated current carrying capacity in the standard does not give a real assessment of the possibility of the conductor when used in real operational surroundings, where the cable is variable with changing ambient conditions. 3. The ambient temperature has a significant impact on overhead conductors, where the lower ambient temperature reduces the temperature of the conductors and consequently increases the load capacity of the conductors, and then the current can be increased more than summer and at night more than the daytime. 4. The current capacity is determined by the electrical and mechanical properties of the conductor and conductor's ability to disperse heat to the ambient conditions. 5. The size of the conductors and the type of conductor material the capacity, where the best types of conductors are copper conductor compared to the aluminum conductor at the same cross section. Thank you for listening.
Thank you very much, Dr. Rafid.
Thank you
for your fruitful presentation. Dr. Haja, we will move on to Dr. Ola, and then you will repeat your presentation after Dr. Ola. So please stay tuned. Dr. Ola, are you with us?
Yes, I am here.
Okay. So Dr. Ola is a staff member at the University of Basra at the chemistry department. She had her PhD from Manchester in nanoparticles and synthesis chemistry. Am I saying it right? Are you, please prepare
now I'm able to share my screen.
Please go on. You are the presenter. The stage is yours.
Thank you. Thank you. Good morning, ladies and gentlemen. I am Dr. Ola Al-Wattar from the Chemistry Department in Basra University and currently on a research leave at the University of Manchester. I would like to thank all the organizers for this great forum, and my sincere thanks also goes to Dr. Suhad for her kind invitation. I'm pleased to join you today to talk about a few parts of my published and submitted work during my research at the University of Manchester. So the title of my talk is The Rational Design of Aqueous Graphene Dispersants. We'll start my talk about like a brief background about graphene and the graphene oxide is just to introduce the topic for the people who are not familiar with this area. Then the aims of the study, and moving to the methodology, result and discussion, and finally some useful application of this work. So let's start to what is the difference between graphene and some other carbon nanomaterials. Graphene is a 2D network of carbon atoms. These carbon atoms are bound within the plane by strong bonds into a honeycomb array composite of 6-membered rings. It is a basic building block for graphiting materials of all other dimensionalities. So as you can see here in this photo, so like it is a basic building block, so it can be wrapped into 0D like a fullerene, or rolled into 1D nanotubes, or stacked on the top of each other to form the graphite material. What about the graphene oxide? So the structure of a graphene oxide has small domains of sp2 hybridization. And as you can see here, it has like a lot of hydroxyl, epoxy, carbonyl, lactones, ethers, groups. So the flake size and amphiolic nature of the graphene oxide leads to some interesting solution properties. Graphene oxide exhibits hydrophilicity by forming hydrogen bonds with water and can undergo spontaneous exfoliation, but commonly sonication is used to increase the monolayer yield. A graphene oxide flakes resist aggregation partly due to strong interaction with the aqueous medium and reduction in by interaction between the graphene basal planes due to the oxidation, but also through contribution from the carboxylic acid functionality. Particularly, if the pH of the dispersion is increased, the conjugate base of the graphene oxide carboxyl groups helps to charge stabilize the dispersion. Typically, concentration of the aqueous graphene oxide dispersion range from 1 to 4 milligram per milliliters, but can be even further. One of the important properties of the graphene oxide is that the pi-electron structure of the graphene basal plane can be partially reinstated reduction or washing of the oxygen moieties, which leads to the production of the reduced graphene oxide and an increase in electrical conductivity. Whilst complete reduction of graphene oxide to pristine graphene has yet to be achieved. The formation of reduced graphene oxide leads to a basal plane surface energy approaching that of graphene, and therefore suffers from the same problem of dispersion. The main advantages of the use of RGO over graphene is the greater versatility with regard to the dispersion approaches, particularly with regard to the scalability and less energetic liquid phase exfoliation of graphene oxide allows size, which can be improved mechanical properties to that of small flake graphene, while still possessing high conductivity. Among the just move to there are like too many different methods to reduce the graphene oxide. Can be thermal or by UV or chemical. So in my research, we use the chemical method. Between all the methods to produce graphene, we use the liquid phase exfoliation, in short term LPE. So, and the reason behind this is like this method, it's a versatility. So we can exfoliate anything, large quantity. So it's very good for mass production, solution processability, and convenient variation of nanosheet size and thickness. And it has like a huge surface area in liquid to do chemistry. So it could be used further in different application. Some of these application I'm going to talk about later. So let's see. This video will help us to understand what we need to functionalize graphene. So mostly the use of water as a solvent in LPE is challenging because of the inherent hydrophobic nature of graphene, which make it difficult to disperse and stabilize in water. So this video show you this. So here we have some graphite on the left and some graphene on the right. When they are mixed with water, you see the graphite start to disperse freely top of the graphene. This is due to the hydrophobicity difference between them. So this leads me to my next point. Now, you might wonder and ask, if graphene is an amazing material itself, why there is a need for graphene derivatives? Well, that's okay. I will tell you why. Some graphene properties limits its applications, such as dispersibility in water and zero gap semiconductors. So which is like a problem for the implementation into semiconducting device. Tendency to aggregate, as I have mentioned, more than 10 layers of graphene behave like a graphite. However, this can be tuned by functionalization. The reaggregation and restacking of graphene layers occurs as a result of the strong interlayer van der Waals forces with a view to reduce surface free energy. So the alteration of graphene surface in order to overcome this issue, and this can be achieved by either functionalization covalently, which is not favorable because it disturbs the aromatic system within the basal plane, influencing the conductivity of graphene, or by stabilization non-covalently, or dispersion of graphene in particular solvent as schematic in this figure. Let's move to the current challenge. So due to all these current challenge, so in order to bring to fruition the great potential of graphene in material science and cognate area of research, it is necessary to develop a robust and scalable methods for the preparation of graphene itself. An attractive method for graphene production, which bridge the gap between academia and industry, utilize LPE of natural graphite into 2D graphene sheets. In LPE, the use of solvents such as NMP, DMF, along with orthodichlorobenzene are commonplace, but their toxicity and high boiling point pose severe limitation in their use on a large scale. In order to obviate these problems, the search for more benign solvents such as water has been the subject of much research, especially from the green chemistry viewpoint. The use of water as a solvent in LPE is challenging because of the propensity of graphene to self-aggregate. And the quest for efficient stabilizer, which ameliorates such effort, has been an active area of research. For this reason, the aim of my study was to use a standard protocol to produce stabilizers for the graphene dispersion, and then we conduct some computational simulation on interaction energy of a stabilizer and the graphene surface, and then we wanted to compare the theoretical and practical results and determine the key parameter affecting the efficiency of stabilizers. To increase both final concentration of a graphene material and lateral size and monolayer count of the flake. Well, so as you can see, we use liquid phase exfoliation for the graphene protection, and we were not the first people who looked into this. We looked at what have been already published in the literature. So this photo shows you the most common graphene dispersants. So you can see from all these structures, all these stabilizers has a hydrophobic part and hydrophilic part. It's something relating to the micelles. Among all these stabilizers, so the pyrene 1-sulfonate, PSA, is one of the most frequently reported small molecules stabilizers in the literature. So building on this, we build a modular structure of a molecule designed for non-covalent functionalization of graphene. A preliminary study, the stabilizing ability of commercial available PSA and pyrene butyl sulfonic acid salt, PPSA, was compared. PPSA was synthesized in 3 steps as shown in this scheme. PSA is effective at producing aqueous graphene dispersion of up to 0.7 milligram per milliliter, but its structure is likely to be far from ideal for this function. Based on a green group study, they observed that the pyrene derivatives with a sulfonyl group yield higher graphene concentration than their carboxylic acid analogs, and also that the 1-pyrene butyric acid outperformed 1-pyrene carboxylic acid. Therefore, it was hypothesized that the insulation of alkyl chain between the adsorption platform pyrene and functional group SO3Na, which is the sulfonic group, would improve the efficacy of the dispersants. So our results indicate that the introduction of a conformational mobile space, in this case of an butyl group between a planar aromatic residue, which is for pi interaction with the graphene or reduced graphene oxide surface, and a polar head group, in our case, was the sulfonyl, the sulfonate residue interaction with the solvent, which is water, generated a molecule, which is a PSA, that was more effective as a stabilizer than the parent compound. Having shown that, like a simple structure change can have observable effect on stabilizer efficiency, and that these effects can be rationalized using computational method and development of the rational approach to stabilizer design and mapping of the exfoliant once bond to the graphene or reduced graphene oxide surface. And this was like a published work in ACS Omega journal. So our result was promising and encouraging us to do more more design development. So to date, there are a few systematic studies concerning the design of a graphene dispersion stabilizing agent, and following the encouraging result from our study of the PSA and PBSA, a modular approach was adopted again in order to generate a similar, a small library of new compounds for graphene dispersants. So the main focus of my research is to identify a new graphene stabilizing agent for the exfoliation of graphene and reduced graphene oxide, with the aim of designing and synthesizing a new asymmetrical substituted of various aromatic cores, asymmetrically substituted with the enthalic group, which was the sulfonic group. So my part of this work is the design and the synthesis of all these library. So within the library, the nature of the adsorption platform, which is like the aromatic part, which is like aromatic footprint, and the spacer between the aromatic footprint and the head group was modified in a systematic fashion. So stronger adsorption onto graphene could increase the dispersion stability, which has the potential to improve concentration as well as the lifetime of the resultant aqueous graphene dispersion. Therefore, the substrates were designed to incorporate different aromatic ring, where we included like triphenylene, pyrene, perylene, and then we use variable alkyl and alkyne chain length, and so the chain length and nature also was variable in our module. And the head group is the same. We keep using the sulfonate group because it gave us a lot of good results. Further to that, computational quantum mechanistic study was also conducted. So as you can see in this photo, so we wanted to know how the molecules sit in on the graphene surface. Is it like parallel or is it like vertical? For this reason, like the computational aid us to give a prediction on how this molecule sits onto the graphene surface. So one stabilizer molecule interacting with the large graphene sheet, which this graphene sheet consists of 1006 carbon atom and 88 hydrogen atom, with the 3 water molecules surrounding the functional group, as you can see here. So the molecule lying flat on top of a graphene sheet, this conformation gives the largest absorption energy, and the computational study gives us the prediction that the concentration of graphene dispersion will increase as the number of atoms increase in the molecule. Okay, so let's move to some application. So for some of the graphene dispersion that we've made using our dispersants, so we wanted to check if it like printable or not printable. For this reason, we like conducted we used like inject printing. So as you can see in this photo, this is like an optical micrograph of an array of printed RGO. In this case, it's RGO dispersion. So we printed this onto a silicon wafer, a graphene, and this photo like show you like AFM micrograph of high concentrated of RGO droplet onto the silicon wafer. And this is the SCM image of low concentration and SCM image of like a large area. So successfully printing dot arrays on silicon wafer, which were characterized for printing optimization. And high concentration deposition allows for single printed drops with an average height 40 plus to minus 18 micrometer. We also like tested this in like a PEL paper just to see if it's printable or not. And luckily was printable. So there is a decrease in measured sheet resistance to 0.3 mega ohm per square on a continuous film when printed into a PEL in formulation with the Triton X. So these films have a continuity after 2 passes given a film thickness of 102 plus minus 23 nanometer due to the lack of aggregation of the RGO flakes, gives the bulk resistivity as 13 plus minus ohm per centimeter. Moving to other like useful application, we did also ink formulation for the graphene with some other commercial ink. So like we have produced ECGs, which is like electrode cardiograms for heart rate monitoring, ECGs, which is our electroencephalogram, and these are for brain monitoring and eye trackers. We also have RFID, radio frequency identification tags, which is similar to what you see on valuable items in shops, and miscellaneous sensors such as like temperature and strain and humidity. And this work is ongoing. We haven't finished yet with this one. So it's still like on a progress. So to summarize, like the synthesis of an amphiolic exfoliant, processing an aromatic bisystem and an alkyl spacer terminated by hydrophilic such as a sulfonic group serves as an efficient graphene stabilizer. The Pmf calculation, which is like the computational study that we have conducted, So this calculation indicates that using a longer spacer chain between the aromatic core and polar head group facilitates the generation of a parallel orientation of the exfoliant into the surface. The electrical measurements and application of these materials in inkjet printing shows a large flake deposition and the potential application of a flexible printed device. So at the end, I would like to thank the Iraqi Higher Ministry of Education for funding me during my PhD at the University of Manchester. And I would like to thank the following people, mainly from the University of Manchester, Prof. Stevius and Peter Quayle, my old supervisor, and all other colleagues. So that's me. At the end of my talk, I would like to thank the all the attendees for your attention, and I would be happy to answer any question you may have.
Thank you very much, Dr. Ola. This is a very fruitful presentation about a very vibrant field of study. Thank you for joining us from UK at the moment. It should be about 8:15 now in the morning.
Yeah.
Thanks for your time. I would like to remind the attendees, panelists or attendees that the Q&A session is open. We are waiting for your questions on the tab specified for that. And before we are wrapping up the session, we would like to have Dr. Haja again to represent her talk briefly and continue with where she stopped. Dr. Haja?
Hi for everyone again. Sorry for the problem that happened.
Never mind.
Unfortunately, I lost internet.
Can you please share the presentation with us and continue with that?
Okay, just 1 minute. I'm just gonna to open. Sorry, just 1 minute until I open the presentation.
And we are still waiting for Dr. Haja. I would take this opportunity to thank and wish best of luck to Dr. Tubi Raihan in her PhD pursuing process, and definitely Dr. Haja as well. I would like to thank Dr. Suhat for the work and for the efforts she put to show the conference in such a way, in such a beautiful way. And definitely we can't forget the behind the scene. I think Dr. Berivan, Dr. Shaheen, and Dr. Ahmed Bahij for such extraordinary efforts they put on preparing this online platform for the conference. I would like to ask all the panelists to open their cams so that we can have well, more like a memorial picture for the attendees while we are waiting for Dr. Haja to share her presentation. Dr. Oda and Dr. Berivan. Dr. Haja, can you open your cams, please?
Okay, sorry, I don't know what's the problem today with my
Well, take your time.
PC. Okay.
Okay. So we got you now.
Should I start?
Well,
Okay.
I think we are a bit short of time, so if you can proceed with where you stopped last time. We still have about
Okay.
10 minutes
So
before
I
the
think
end of the session. Sorry, start of the QA session.
I will just start it from here. From the point that I stopped, that I said that about the diagnosis of bladder cancer by using particle, as we said before, we have two other different methods that can be used for diagnosis of NMP, which is the result for bladder cancer. But these two methods, which is so cost-effective, we will try to find a new way, and maybe in future we are going to make it paper-based test, which will be cost-effective, and it is simply everyone can test for this cancer, and we will be useful test. So according to our work, which is happening to this internet.
I think there's a problem with Dr. Haja again.
This internet today is really so bad. I don't know what's as I said that we synthesize the carbon dot by mixing citric acid and uric. As I said that we synthesize carbon dot by mixing acid and for 6 hours, and then we get the carbon dot nanoparticle. We measure the fluorescence of our nanoparticle, and you can see it has a fluorescence, but the fluorescence is too low. After that, we conjugate these nanoparticles by EDC NHS, which is bioconjugated with antibody. After conjugation between nanoparticle and antibody, the fluorescence is enhanced for the carbon dot, and we measured the fluorescence. Then we added our target, which is NMP, and which make a large particle, and the fluorescence again is checked by photo. It's clear the fluorescence decreases, and also we take the fluorescence by instrument, and with different concentration of our target, the fluorescence decreases gradually, or we can say the fluorescence quenched gradually. For the next, we take it for characterization of nanoparticle. We just make it HRTM and TEM. With the HRTM, we can see the size of our nanoparticle is 4 nanoparticle, and the size distribution is told as that the most of our nanoparticle that is synthesized by our method, it have 4 nanometer in diameter. And also we take it the absorbance and fluorescence for our nanoparticle, which is ensure that we have nanoparticle, we have 2 different peaks in UV visible, and also the emission peak at 500 for fluorescence. To prove that we take the FTIR for each one separately, we can see that the peaks that formed after conjugation of antibody, which is two kind of peak, which is amide, it's called amide peak, and we get these two peak nanoparticle is conjugated with antibody. Then fluorescence emission for carbon dot alone, and with carbon dot alone, the red is the blue one. Then we did the study of effect of concentration of carbon dot, nitrogen dot, carbon dot conjugated to MAB, monoclonal antibody, on the fluorescence intensity and effect of pH value on the fluorescence intensity. Then we study the stability. As it's clear, we have we get maximum concentration at this point for the antibody, and the best pH for the working, which is pH 7, and also the reaction is start to be stable after near to 13 minutes. After that, the reaction remain stable. For the calibration, we use different concentration of NMP, and we started from 0.2 to 22.9 nanogram per ml. We can see with increasing concentration of protein, the fluorescence quenched gradually. And we have the calibration curve for it, and which we get the R square 0.99, which is a very good results. We can depend on them on future. The study of interference, the selectivity of our probe, the fluorescence probe that we synthesis, was evaluated by testing response of the fluorescence probe to multiple coexisting substances, the substance that may be present with our target in the urine, because we use it urine as a sample for testing. Maybe it will contain BSA, glucose, vitamin C, and also cytochrome C. This use it as the interference, and we don't see any interfering between them when for studying the selectivity of the probe. The result confirmed the excellent selectivity of our probe, and we also study the real samples. We have different real, we use a different real sample, and we study the recovery. As you can see, we have a very good recovery for our works, and also the RSD is also a kind of result that is hopeful, and we can in future depend on them for other works. And thank you for attention, and I'm sorry for the big problems that happen, really.
Thank you again, Dr. Haja, for the presentation and for your effort that you put on this work, and best of luck in your PhD. Now, can I ask for one last time to open your cams all at once so that we can take that picture we were asking for. Dr. Haja, can you please turn off the sharing?
Okay, 1 minute.
Can you stop the sharing? Okay, so is Dr. Rafid still with us? Dr. Sidqi, Dr. Berivan, everyone else? If you are still with us, please turn on your cam so that we can take that picture. Okay. Now the second picture, and that's it. So now the session is open for discussion. I didn't receive any question yet from the audience, but does anyone has any question? Okay, so I will start with the easiest for the PhD students, Dr. Rayhan and Dr. Haja. Dr. Rayhan, what is your plan to extend your study? I mean, at some point you have presented a substance to make some purification. How can you extend your study?
Doctor, in my PhD, until now, we don't choose plants because, as you know, until now, just we finish our course before 2 or 3 days. Yes. But in the work, we use Orgies as a source of phytochemicals or antioxidants. Yes.
Thank you very much. What about Dr. Haja?
Okay, for future work, actually, I just wanted to tell you that about near to 1 year, I just published near to 8 articles. All of them is in a very good, and some of them in a high impact factors. For future work, I'm just going to work on some paper-based biomarkers for making easiest to be helpful and low cost for detection some disease. And also I'm going to synthesize different and some novel nanoparticles. Actually, I have worked on synthesis of some magnetic nanosheet, which is novel from some waste compounds. And I'm going to improve my field. So I don't know what I can do, but after my defending of my thesis, maybe I just start working on paper-based tests.
Okay, best of luck. I would like to ask, all your presentation was about diagnosis of bladder cancer. Is that correct? Okay.
Yes.
So is there any method that you, well, like similar approach to treat that cancer?
Yes,
so
actually.
Yeah, and maybe my second question is, how early can you diagnose?
Yes, actually, the test for my for the paper that I discussed here, I get result in 13 minutes. Actually, each diagnosis test for cancer, it take more than 1 week or several days. So I just as I mentioned, we can just get result by 13 minutes. It's a very fast method, so we can depend on it. And for as a therapy or treating, we can in future, maybe we are working on drug delivery by using nanoparticles. So we can go to the therapy of cancer disease also.
Again, sorry, when I asked for the how early, I meant regarding the time of the disease. Does the patient have to be like in a very late time,
yes,
or we can have it on early stages?
Sorry, I understand it in a wrong way. According to the results that we get, we can diagnose by this method in a very early stage. We can say just few starting change in DNA, we can diagnose, and the treating, it will be very easy if we can diagnose in this stage. Yes.
Okay, thank you very much. sorry, Dr. Rafid, I haven't been with you for most of your presentation. Well, from your own knowledge, can you give some of the applications that you can use for the the application that we can use it for the presentation that you have?
Yes, thank you very much. Thank you for Dr. Suad Yassin for this invitation. Thank you. My application is on electrical networks. Yes, this is a very applicable paper because by this paper we know the most applicable wire than the others. Because the heat dissipation in wires is very high, and generated fast electrical current through these lines. From this paper, we concluded that many wires is applicable in the south of Iraq than the others.
Well, in this case, I'll move to the other question. With the current high temperature we are witnessing in Iraq, especially as you said, in the middle and the south of Iraq, where the temperature can rise up to 50 and maybe 60 in some oil fields.
Yes.
Can this concept still be applicable, or do you have to move to some modification or some preparation or some?
Yes, there are some modification for cables and wires. There are two types of electrical wires and cables. There is some problems in anyone, and there are many modifications because there are many types of wires such as ACSR, ACAR, triple AC. There are many types, but and many cross-sectional area. We concluded some modification on these wires in south or middle of Iraq.
Great, thank you very much, and thanks for giving that lecture, Dr. Suhad. Dr. Suhad.
Thank you, Dr. Omar. Doctor, I have one question to Ms. Rayhan. Do you think we will get a better result if we select another plant?
Thank you, Dr. Suhad. Of course, yes, maybe. Changing a plant means you change the phytochemicals concentration inside the plant, which is the basic reducing agent. Therefore, when you change your plant and phytochemicals change, you produce nanoparticles with different size, morphology, and agglomeration diversity of nanoparticles. And another reason, if you change your plant, of course you change your pH. And there are plants with acidic pH, with such as orange, but other plant like banana has basic pH. Therefore, the nanoparticles produced through the using of banana, which have basic medium, of course, it is to be metal oxide rather than metal. In addition of change of a plant, there are other dependents. For example, the region of a plant, the age of a plant. I hope that I answer you.
Thank you, Rayhan. Dr. Omar, please. Just I want to have one comment to Dr. Ula. Thank you, Dr. Ula. Please, Dr. Ula, we need to transfer your expertise in the field of graphene through collaboration work from Basra to Duhok.
Yeah, that's great. It's my pleasure to do that. We can like have a private discussion about this if you want,
Inshallah, دكتورة.
inshallah.
Dr. Ola, what I'm interested in your work is that what kind of devices so far have been developed from graphene?
So yeah,
Semiconductor devices.
currently we have about two. One is like a composite for something like it's related to the semiconductors, like this thing. But this is still, we already like make this. It's just to clarify, this is like a teamwork, is not like individual work. So my like part of the work that I talked about is just designing, synthesizing, and you know, we can't progress any work without like having a teamwork. So
Yes, sure.
we like produce this semiconductor device, and also we produce, as I showed you, like ECGs. It's just to monitor the heart rate. So instead of having like the device where which makes like all your body, you need like all your chest for this device, but with our device it's like something like a tattoos. You just put it in your chest and that's it. It's just sticky to your chest. It doesn't have any like harmful effect, and it gives us a really good result. So I didn't go in deep details on this. We have like tried this not in a human, because you know, in UK it's not easy to try this in a human in the beginning, just in case if there is any toxicity effect like these things. So we try this like in a 3D print. Our colleagues like design a head, which is called like a phantom, and he put like electrode and anode and tested everything. So everything went fine. So basically you can say we have two devices till now, but it's this part of work is still like under investigation. We want to produce more.
Enough. That's what I'm interested in, because of my background. I've heard so much about the degradable devices that we can inject in human body. Can the graphene be one of these devices? I mean, is it soluble? Can it be solved and just degraded within the human body
No, I
without
don't think it's usable inside the body, because it's not the graphene itself, as I mentioned, because the graphene is not soluble in water. This is the problem with the graphene. For this reason, there is a need for the stabilizer, is just to help its dispersibility in water, just to make it dispersible and stable in water for a long time. So the stabilizer that I have made so far gave us a really good like result, because it helps with the dispersibility in water, and gave us a long time for the graphene dispersion in water. So till now it's okay for the like in vivo, not in vitro.
Okay. Thanks for all participants. We do have a space for one last question, if someone would like to ask. Okay, so in this case, I have nothing to say, just to thank everyone for attending this session. Special thanks to the speakers today, and like a big thanks to the organizing committee, starting with Dr. Suhad and with everyone else. Hope to see you soon in Duhok in Kurdistan and in Iraq, and all the best in your work in the future. Thank you very much, and have a great rest of the day.
Thank you too. Bye.
Bye-bye.
Bye. Bye.